next 25 to 30 minutes, what I will show you is more or less what you have learned already, namely how you understand the loop or performance breakdown of your code using a different tool. And I can describe this different tool as not vendor independent, but it is more platform independent, so you can run it on different platforms, different x86 platforms. Because we recognize that we have some attendees are not necessarily Cray system users. So we are not doing hands-on because it's a short session, but I would really like you to bring up the GUI. So the idea is there is not one way to identify and fix a problem or resolve an issue. What I am hoping to convey here is to show you what you can do, what the tool can do. And for the most part, you would learn by doing it yourself in your own way. So in this case, I will show you some key features and example, but I would really encourage you to try, if I can say so, to break the tool, because that's where you will learn the most. So if you are on Pilatus, and if you have a node allocated, you should be able to launch the graphical user interface, which is called AMP-XLE GUI. Can you launch it without a problem? Anyone? Okay. So we are not going to do more work. The other thing which you have to keep in mind as you learn and do different applications, and you can later on use it today when you do hands-on, that you should try compiling with -G, where you can get the debug or more function name properly. So for now, you can maybe stop looking at your screen if you want, unless you have an important email or a message. And then I would walk you through some of the screen interfaces. So I think I only have something typed on my last few slides. Rest are just screen captures of VTune. I think it's probably working. So you see like that. When you first pull it up, this is what you see. And it's quite explanatory. It says that, okay, if you have an existing project, you can open it. If you have an existing result that your profile you have generated with VTune, you can open that thing. You can start a new project. What I would recommend is start a new project and generate as many profiles and compare them. And then later on, you can decide, okay, I don't need that much information all the time. But for the first time, don't try to clean up as you start learning this tool. So let's assume we are doing it for the very first time. I'm going to open a new project. So when you say open, as you can expect, it says, okay, give me a project name. And you can go and change your directory, as you could imagine with any other interface. So in this case, I used one of my colleagues' example, which you will learn later today and tomorrow, this Laplacian code. So I say, okay, I want to create it not where VTune is telling me to go, but somewhere else where it makes more sense for me. So I change it. No complicated. I name it lap VTune. You can choose something probably more meaningful. And you're pretty much done. Now, the next thing you have to do is you have to specify an application name, which is your executable. You can specify by going through browse. That's pretty easy. And then other things you can do, you can specify application parameters. So maybe your application will take few parameters, in this case, which is true. And you can also change environment variables. And then you can try clicking and opening things and try to learn a little bit more. And then you can change the target type, what you want to do with this application. So I specified I had an executable generated already, but you can generate it on the fly as well. And it's like that. Then I say, oh, I want to mention few parameters. The example I have, it takes 3 parameters. So I say that, okay, these are my command line parameters. And then I also want to have a user-defined variable, which is nothing more complicated here. It's just the number of threads my OpenMP application uses. And as you run the code, you can change it. I will show you. Then you can run it at 4 or 8 as you are profiling and improving or tuning your code. And that is pretty much it. So you are all set, more or less, to get started with an experiment or with many, many experiments. OK. The thing to note here is that arrow thing on the top, just before the file menu, the third one from the right. When you click that button, I think I should have pointed something there, it says that, oh, what type of analysis you would like me to do? From a high level, you have 2 types of analysis. One I usually define is a platform-independent analysis. It's an analysis of your code, which is more or less going to be true regardless of any system you are running. And you see it on this column on the left. So you can scroll up and down and read about it. So the first bar is more general exploration or platform independent kind of analysis. You can do it just to see how your code is working on any platform. The second and probably more important as you start tuning your code is what we call more platform-specific tools. So further down on that list, you will see they have a set of analysis for example, Westmere or Nehalem type of processor, set of analysis for Sandy Bridge processors, et cetera, et cetera. So then if you think you are not more focused on tuning on a given platform, then you can choose the other one. I will show examples of both. Any questions so far? OK, let's keep going then. So this is my general analysis. I say, OK, can you just go in and do hotspot for my code? And it should come back very quickly. I just have 1 thread, and it says that it gives me a summary. OK, this is the time it took to run. It lists the function that are the hotspots. And then it gives like a generic information, which platform I ran on, what type of processor, compiler, et cetera, et cetera. So it's kind of a summary for you. And the good thing is this result is stored. So whenever you want to review what you did in analysis, hotspot analysis, all you have to do, even after you close, shut down, and go back after a month, this will be there. You can just pull it up using vtune. In this case, again, this is hotspot analysis, so it gives you function breakdown. On the lower part, since I just ran it with 1 thread, it shows you how the thread ran, how was CPU time, like more general things. The other thing you would notice would be this drop-down thing. And to bring this up, I use the top button, which is called bottom-up analysis. And then you can also do top-down tree analysis, where you can see like the call tree. You can click a lot of things there. I'm not showing you each and every things you can click on, but trust me, there is more useful information everywhere. So in this case, for example, I wanted to do top-down tree going from start all the way through the code. Since this is a simple 1 file, so it's not probably that meaningful. But you can see the time and the function breakdown. Again, it's platform independent. It's just about the profile, or what I typically call flat profile type of generation. So this is essentially what you did for probably AP2, Apprentice 2. You saw the function breakdown. You saw the call hierarchy. So it's nothing fundamentally different. And you can do the same thing. For example, if you are working on a non-Cray platform and you want to do OpenMP, but you want to know where to start, you can do something probably similar. It won't do scoping for you, but in this case. So this was all about platform independent. Now we are going to a more platform specific. And the idea is I want to tune my OpenMP or just any code on, for example, in this case, Sandy Bridge system. So you know PISDAINT, you should be able to tune it on that system. And there are a number of analysis you can do. There is general exploration, which is like hotspot analysis, but a little bit of additional info. Then you can do memory bandwidth analysis. This is very important. I'll show you how you do it and make use. You can also see access contention, branch analysis. Typically, what I do general exploration, bandwidth analysis, loop analysis, memory access. Depending on your code, you may want to do port saturation, how you are using this. You can do cycles and micro-ops, et cetera, et cetera. So for each of this analysis, you can go in and read about it. They have a little bit of documentation. The thing to note here is on the right side, you have start, post, and project properties. So you can always pull up project properties here to change anything you defined earlier. So you just learn to start navigating it, and once you do it, you will be just fine. Now, in the summary part, there is some key difference. I did just like a general exploration. GE is for general exploration. But now, since I have done a platform-specific analysis, the tool is helping me to find problems. So the pink highlighted thing is, it says, look, this is something that is not making good use of the system features. I am seeing too many machine clears, for example. Sometimes it will highlight the CPI rate, depending on how you do it. So, and it tells you like a little bit of more additional information. Then they say unfilled pipeline slots, and you can open those up there, and then it would highlight in pink something where it says pay attention. So whenever you are working on vTune and you see something pink, or depending on how you describe this color, it means that pay attention. On a given platform, this behavior is probably causing you a slowdown. And we'll see what this really is. But that was summary. So I really want to know, okay, I know I have a problem, but where is it exactly? If you have many, many files and thousands and tens of thousands of lines of code, that's probably not helpful. So you really want to know where the problem is coming. In this case, you can say, now, after summary, typically you would go to bottom-up analysis. So you click that button, and it floods you with additional info. But the good thing is it then also highlights the pink parts, and you can double-click on them, and then it would go in and point in your source code where the problem is coming from, which is, I think, very important and very useful. Because the numbers themselves are meaningless. You really, really want someone to help you to locate your problem. Someone, of course, to help you fix the problem, but that part is not quite there. But being able to locate and identify on a certain line number where something is coming from is, I think, quite useful. And this is really what I did. I double-clicked it, and it says, OK, I'm taking you there where the problem is coming from. And it's sort of, I couldn't show everything on this screen, but it shows you based on because this is platform-specific analysis, number of hardware counters that it is generating there. And then you can see, if you just start scrolling down the tab, it can say, oh, on the most expensive function, my CPI rate is cycles per instruction is very high, and the lower level cache hit is kind of problem. And the machine clears are an issue in the other ones which are running much faster, the loop version and the vectorized version. I click it further, I keep scrolling it, because I want to see where I see those pink lines where I have problem. Because if you see that the other parts the Laplace loop and vectorize, they are not taking too much time anyway. So I can ignore those pings and I can focus on the parts that are really, really important. So as you can see that you are not really making very good use of your cache in the most expensive part. And you can start hovering your mouse to see what those features are. So, and then whenever you want to see, you can double click it and it will take you to the code. So it's not too difficult to figure out. You are having some serious memory access problems there. And as you will see in the example you will do, even if you try vectorizing the code, it won't help because it is a more memory-oriented problem. So from that general analysis, I see that, okay, I know I have some kind of memory-related issue or problem. So it may be the case I'm not using my memory bandwidth correctly. So why don't I do a follow-up analysis, which is a bandwidth analysis? So I again click that top button, new analysis, the right just below the menu. I think I should use this thing. Always remember to click this one. It opens the new analysis box. And then I go here and I click bandwidth here, and then I start analysis again. And it tells you here, what type of analysis are you doing? You can click this thing and it will open details for you. It's really verbose. So because I'm doing a platform-specific analysis, so it will tell you what hardware counters I'm going to collect. And I wasn't interested. I said, just tell me if I'm using memory bandwidth correctly or not. I'm not interested how you are going to measure it. So again, I run it. And whenever it runs, it gives you like it's quite helpful, which is okay. And it tells you for bandwidth, this is what I did, and there are some recommendations you can do. So there is some summary. Now I don't have a lot of information here. So whenever you run, you always get a summary page, and then very quickly, unless you see something highlighted here, the normal course of action for you will be to click bottom up. I click bottom up, and now I only see two most expensive loops. The third one goes through very quickly. So there are a few things important here, and since we have been focusing a lot on memory and a lot on cache-related issues, I would spend a little bit more time here. So the first part you see here is bandwidth, is both read and write bandwidth, and this is your read bandwidth. You can choose, I will show later on here. But the first thing I do is, because my eyes are bad, so I want to make it a bit bigger. So I say, okay, show me something where I can read properly. So you can go back and forth, depending on how you are doing analysis. So what I see here is, okay, when I start the code, I see very low bandwidth. Can anyone tell me why I'm seeing package 0 and package 1, package 0 and package 1 here? It's a Sandy Bridge system, it's Pilatus. We have two memory regions. So when you start doing experiments with the NUMA controller memory affinity, try fixing threads here, different parts, and see if you see this thing moving up and down. Or in some cases, you can get a whole thing filled up as well, depending on how you are using it. So it means that, so for Interlagos, I haven't tried it, where we have 4 NUMA regions. In theory, we should see 4 of them here. But since we are doing just one thread, so it's okay we see something like that here. So I see pretty consistent pattern, and I can see there is certainly some kind of problem here. And okay, it's highlight CPI again, which doesn't help much. So I want to see where exactly in my code I'm seeing this behavior, where exactly in my code I'm seeing this behavior, and where exactly in my code I'm seeing this behavior. And if it's a very long running code, you might want to zoom in kind of further. And you can do it. So first, I want to show you what happens if you run with more than one thread. So I went in and I tried running it with more than one thread. So I can see a bit more profound pattern with the code. And now you see, you have really, really jaggedy behavior here and fairly consistent. And if you hover your mouse over there, you can see, oh, here my bandwidth is about 19.6 gigabytes per second. And in the jaggedy part, I have like a quarter of that. So what I do is I really want to see what is going on here and why I'm getting this behavior. So you just right-click here. You say, OK, I want to zoom in that selection. And you can choose whether zoom in and filter or just zoom in depending on what you want to do. So I said I don't want to just select. I just want to focus on that part. And if you see, when I selected this part, it automatically highlighted the function where I see this problem. So depending on how you are making this selection and depending on how you are doing this grouping thing, you can narrow it down to the part where you are really seeing some troublesome behavior. I'm not going to say how you fix it or whether it can be fixed, because this is something you will learn later on when that example is going to be done. The other part I want to show is, especially for if you are doing OpenMP programming, is loop analysis. Again, among all these things, after general exploration bandwidth, I could have done some other analysis, but I chose to do loop analysis because we are doing OpenMP course. And when I do this analysis, I say, OK, this part, I want to look at the hardware issues, because really I'm focusing on the code. And I converted my code also to OpenMP. I see the problem here is data TLB. You should all remember what Neil told you about TLB. If you have a problem there, means you have a serious problem. And then you can try. So you compare to what you saw in CRAPAT and in earlier analysis, here you have this ability to go at the loop level, at the function level, but also you can learn how the hardware is reacting as your code executes, and then based on that you can try fixing the problem. The other thing which is also important, because this is something we will probably do over and over again because it's all memory related issue, is memory access analysis. And as it says, identifying using events. And then it collects a lot of, so it's memory load, micro ops, lower level cache hit. So mostly the level 3 cache issues it will do. What you can do then, as you do your analysis, you can select or filter by event if you know what they are. I typically look for misses because that tells me, OK, I have a problem, but there could be other things that could be useful, like loads and stores. And then you can see that which part of the code where you have more loads versus more stores. So in this case, I have selected load op, and I see is I'm doing all low-level loads in one part of my code, while in the other part of my code, I'm pretty much working off the caches. So it was a really, really quick overview just to tell what you learned from Reveal or App2. It could be done from a non-Cray tool. We have it available on Pilatus. I'm pretty sure we'll make it available some way once we have the other Intel-based Cray systems. But most of the CSCS Intel platforms have that. And of course, once you have a code tuned, you can try running the same code on a Cray platform. So you don't need to memorize anything. I would encourage you, when you start doing exercises in between that, try to go through some of these slides. I have copied them in the slides directory, and see if you can see or learn from what you see. Make sure you have -G in your make file. As long as you verify input parameters, you select your environment variables, you should be okay. Make sure you are doing platform independent or versus platform dependent analysis. And depending on what your goal are, you can decide. I would expect we are going to probably be spending most time doing platform dependent analysis, but otherwise it's also fine. And as you are in the learning phase, that's what I did myself. Try to run as many experiments and try to explore the tool, because you may end up doing a completely different sequence of operations to find and fix your problem that I have shown you, because we don't know where the problems are. But when you are in the learning phase, try to do as many, and try to use the feature of comparing multiple results. Choose options and filters as needed. Explore tabs and utilities is very important. I mean, I can show you that much in half an hour, but I would really, really encourage you to try out things that may be useful for you. And most importantly, this is, I mentioned the last one. I'm out of time, so I should finish very quickly. I have just 2 more slides. When you learn the vTune interface, the thing that can happen is there are other Intel tools, and we are thinking of making them available, but the interface is quite similar. And what I mean is, these are some links, so it's like that. So this is I copied from Intel website, so it's nothing special. But the reason I copied here was just to show you, once you start learning to navigate in vTune, you can use their tool which helps you find memory issues, like memory problems and race conditions. So if you are comfortable with that, you can really make use of this tool, as well as something which is very close to Reveal, which they call Intel Advisor. We haven't tried it. This is, as Themis said, we are going to invest some time learning these tools as well. That you can also have something similar where you can not only identify a problem, but it can suggest you what you should do in terms of parallelizing and optimizing your tool. So with that, I stop. A few minutes over time. Any questions? Next 25 to 30 minutes, what I will show you is more or less what you have learned already, namely how you understand the loop or performance breakdown of your code using a different tool. And I can describe this different tool as not vendor independent, but it is more platform independent, so you can run it on different platforms, different x86 platforms. Because we recognize that we have some attendees are not necessarily Cray system users. So we are not doing hands-on because it's a short session, but I would really like you to bring up the GUI. So the idea is there is not one way to identify and fix a problem or resolve an issue. What I am hoping to convey here is to show you what you can do, what the tool can do. And for the most part, you would learn by doing it yourself in your own way. So in this case, I will show you some key features and example. But I would really encourage you to try, if I can say so, to break the tool, because that's where you will learn the most. So if you are on plot, then I would walk you through some of the screen interfaces. So I think I only have something typed on my last few slides. Rest are just screen captures of vTune. It's probably working. So you see like that. When you first pull it up, this is what you see. And it's quite explanatory. It says that, okay, if you have an existing project, you can open it. If you have an existing result that your profile you have generated with VTune, you can open that thing. You can start a new project. What I would recommend is start a new project and generate as many profiles and compare them. And then later on, you can decide, okay, I don't need that much information all the time. But for the first time, don't try to clean up as you start learning this tool. So let's assume we are doing it for the very first time. I'm going to open a new project. So when you say open, as you can expect, it says, okay, give me a project name. And you can go and change your directory, as you could imagine, with any other interface. So in this case, I used one of my colleagues' example, which you will learn later today and tomorrow, this Laplacian code. So I say, okay, I want to create it not where VTune is telling me to go, but somewhere else where it makes more sense for me. So I change it. And if you have a node allocated, you should be able to launch the graphical user interface, which is called AMP-XLE GUI. Can you launch it without a problem? Anyone? Okay. So we are not going to do more work. The other thing which you have to keep in mind as you learn and do different applications, and you can later on use it today when you do hands-on, that you should try compiling with -G, where you can get the debug or more function name properly. So for now, you can maybe stop looking at your screen if you want, unless you have an important email or a message. And